Good morning, children. We will move on to the next portion. Hope all of you have drawn the ray diagrams of convex lens as well as concave lens in your physics notebook. Next, what we have to study is new Cartesian sign convention and the lens formula. So, as you have studied in mirror, here also we have to consider the sign convention. So, in the case of mirror, pole was considered as the origin. Here, the object center is considered as the origin and the light ray is considered to be falling from left to right. The distances marked along the direction of light ray is taken as positive and the distances marked opposite to it is taken as negative. The distances marked upwards from the principal axis is positive and the distances marked downwards from the principal axis is negative. Then the principal focus of a convex lens is taken as positive because for a convex lens we take the focal length on the other side. So the focal length of a convex lens is taken as positive and that of a concave lens is taken as negative. So while considering all these sign conventions, we will move on to the next portion or the next heading is lens formula. So what is lens formula? So you have studied mirror formula. Mirror formula is 1 by f is equal to 1 by u plus 1 by v. So here there is a slight change. That is lens formula is 1 by f is equal to 1 by v minus 1 by u. So you have to do the problems regarding this formula. 1 by f is equal to 1 by v minus 1 by u. The problems will be discussed by your teacher in your physics class. Now, another thing that you have to study is magnification. Magnification, as you studied in mirror, it is the ratio of height of image to height of object. Or magnification, what you studied in mirror is m is equal to minus v by u. But here magnification is, you need not write this minus, m is equal to v by u. These are the two formulas that you have to study in this portion. That is in the lens diagram. Lens formula is 1 by f is equal to 1 by v minus 1 by u. And magnification is hi by ho, or else magnification is v by u. Then we will move on to two examples are given in the textbook that your teacher will be discussing. So magnification, if the magnification is negative, then it is a real image. Real means it is inverted image. Magnification negative means it is a real inverted image. And if magnification is positive, it is an erect virtual image. Understood? So we will move on to a problem regarding magnetism, that is let us assess page number 6. Page number 138. Sorry, 128. Let us assess question number 6. What's the question? An object of height 3 centimeter is placed in front of a convex lens of focal length 20 centimeter at a distance of 30 centimeter. So the question is, what is the distance to the image formed? What is the nature of the image? And what is the height of the image? So what all things are given? An object of height 3 centimeter. So we will try to draw the rough ray diagram. An object of height, so is placed in front of a convex lens. So a convex lens is drawn. Then an object of height 3 centimeter. So the height is given 3 centimeter is placed in front of a convex lens of focal length 20 centimeter. So this is the optic center. Focal length will be somewhere here. Focal length is 20 centimeter. Focal length 20 centimeter at a distance of 30 centimeter. So this distance is 30 centimeter. You have to find out V and the nature of the image. So what all things are given here? U is given. U is always on the left side. So U should be taken as minus 30 centimeter. Then focal length. Focal length of a convex lens is taken as positive. So 20 centimeter. Then height of the object is just an erect object. So HO is equal to 3 centimeter. You have to find what all you have to find. You have to find V and also HI. So what is the lens formula? Lens formula is 1 by F is equal to 1 by V minus 1 by U. You have to get V. So you will take this minus 1 by 2 to the side. So what will it become? 1 by F plus 1 by U is equal to 1 by V. Minus 1 by U, when it goes to the left hand side, it becomes plus 1 by U. Then you can cross multiply. U plus F by Fu is equal to 1 by V, or V is equal to Fu by U plus F. This is the formula. Then you can substitute. V is equal to Fu by U plus F. So, how will you do? Fu by U plus F. So, V is equal to F. F means 20 into minus 30 divided by minus 30 plus 20. So 20 into minus 30 by minus 10. That is equal to 0, 0 cancel. Then minus 20 into minus 3 will be 60 minus and minus, it will become plus 60 centimeter. So the image is obtained on the other side of the lens. Other side of the lens means it is a real image. So this is the A part. Then B part is what is the nature of the image. So image is obtained on the other side of the lens. Since V is positive, V positive means image is obtained on the other side. So the image will be real. Real image means it is inverted also. So the image will be real and inverted. Now we will move on to the C portion. What is the C portion? C portion is you have to find out the height of the image. So how do you find out the height? M is equal to HI by HO. That is equal to V by U. So HI you don't know. HI by HO is equal to 3 is equal to V. What is V? V is plus 60 by what is U? U is minus 30. So HI is equal to 3 into 60 by minus 30. That is 3 and 30 10 times, 10 and 60 6 times. So the answer is minus 6 centimeter. Minus 6 centimeter means, here already we have written, since magnification is negative, this is a real and inverted. Then, what is the height of the image? Height of the object is 3. And what about the height of the image? Height of the image is 6. So 3 has doubled. So the image will be a magnified one. The image will be magnified. So here we have come to the final answer. Next we have to study is another topic that is known as power of a lens. You might have seen when you have gone to a ophthalmologist, After examining your eyes, the ophthalmologist will give the prescription as the lens what you have to use. And there is a prescription that is either plus 2D, minus 2D or something like that. It will be given in the prescription. So what is power of a lens? Power of a lens is a term that is related to focal length. Power of a lens is a term that is related to the focal. Power is reciprocal of the focal length when focal length is measured in meters or when focal length is expressed in meters. Power is the reciprocal of focal length when the focal length is expressed in meter. So P is equal to 1 by F. The important point is F should always be expressed in meter. And the unit of power is diopter. And then case is the power of, since the focal length of a convex lens is positive, power of a convex lens is positive and power of a concave lens is negative. So how is power found? Power is the reciprocal of focal length where focal length is measured in meter and the unit of power is diopter. Understood? So this is the power of a lens. Then regarding this power of lens, there's a question given there in letters SS. Question number 4. What do you mean by power of a lens? Power of a lens is a term related to the focal length. Power is the reciprocal of focal length where focal length is expressed in meter. Then what is the SI unit of power of a lens? SI unit of power of lens is diopter, D-I-O-P-T-R-E, and is represented as capital D. Then the question, calculate the power of a concave lens of focal length 25 centimeter. So power of a focal length, power of a concave lens of focal length 25 centimeter. So since this is a concave lens, focal length is negative. Then you have to convert this centimeter into meter. So how will you convert centimeter into meter? Divide by 100. So minus 25 by 100 meter. 25 by 100 will give you 1 by 4. Then what is the power? Power is reciprocal of focal length. That is 1 divided by minus 1 by 4. So 4 will go up. So the power is minus 4D. This is how you find the power of a concave lens. Next in your lesson, it is given atmospheric refraction. That is a small portion. Atmospheric refraction, there is a question there. Why do stars appear to twinkle? Why do stars appear to twinkle? That is, the light coming from stars have to pass through different media of different optical densities. So when light passes through medias of different optical densities, light gets refracted. Light gets refracted successively. So the source of light, due to this refraction, due to this bending of light, the source of light appears to be twinkling. So there's a paragraph given in your textbook. Why do stars twinkle? See that light coming from distant stars passes through different layers of air. Each layer differs from the other in their optical densities. Hence, light undergoes successive refraction. Since stars are at a greater distance, they appear like a point source. Point source you have studied in your smaller classes. A small source of light is known as a point source. Even though stars are very big, bigger than the sun, since they are very far away, it appears as a point source. Then, the rays of light appear to come from different points on reaching the eyes after refraction. So, the rays of light that is coming from the star that is far away refracts many times. So, we feel that the source of light is coming from different sources, and that is the reason why stars appear to twinkle. So from this, we have reached the end of the lesson. Let us assess 3 or 4 questions are remaining. We will give it in the next class. So thank you.